Sorry. Sorry about making you subscribe. We're just having a chill, like subscribers only. It's an easy way to have a chill stream that has fewer dumb comments and is less draining on my energy. So, oh, I meant to make the entire stream sub only. It's just it resets after every time. So I hit the stream button and then I checked and I was like, "Oh, it reset." So I stopped the stream and I reset the stream in sub only mode. So I'm watching the CS game right now, and I'm not sure how much of the CS game to watch versus just start programming. I mean, Astralis might just win real fast. I legally have to explain what exactly this is. I explained it yesterday. You can watch the start of yesterday's VOD. Dude. Oh my god. Is the Pixar mug better than their latest movies? I got it in 2019, way before the latest movies. Don't tell me I can actually be productive while watching a stream. I mean, it depends on how much I'm watching, right? Like the amount that I'm watching right now, I can't be productive. But if it's just like on in the background and you're kind of ignoring it, then yeah. Maybe Astralis isn't going to win so readily. Ouch. I actually, did I do some work off stream? I did do some work off stream. I did probably an hour and a half or 2 hours last night. This whole file that you see here, I typed last night. Also, I finished some of the other stuff. Anyway, so what I'm doing right now is I'm writing some code that'll export this to the visualization client. And now I'm watching Counter-Strike again. Ooh, nasty. Rip. Rip. Anyway. So I'm basically making a message in the shared memory that's big enough to hold a bunch of these stack trace summaries, which is going to be quite big, actually. At this point, I'm not watching the Counter-Strike seriously enough to really enjoy it that much, so I wonder if I should just stop and just program. These are the dilemmas that we have. These are the dilemmas that we have. I don't know what people think about this. I think we'll have to program. Oh, after this round. Ow. Seems like it might be a long game then. Okay, how's it going, everybody? So I'm gonna go start some tea water, and then we'll come back and keep going. So what I'm in the middle of doing here is I'm just making some messages that contain all this data about what is going on, so that we can draw them on a visualization client. Now, there is no visualization client yet. We will do that part as well as soon as I finish this part and get it to compile. And I'm not even going to do this part that seriously, because all we need to do is send some data over and get it being received correctly. And then we can see, oh, you know, I just realized here I'm dang it. You know, I kind of just want to make a little data structure for this. Because that's the whole thing is like, look, it's shared memory. Like, we could just do the, yeah, you know, this is going to be more readable. Instead of doing all this stuff, let's do this. Let's do this. So we have this viz protocol tag. We have the address. We have the hash, which is we're trying to do this. We're trying to send these packed stack traces. Okay, that's a hash. All right. We have the address. We'll just do this. Doesn't have to be a void star. Nodes is an S32. We'll pack that up there. And then we have alignment. Okay, so now we're going to go bytes is size of stack traces info. Okay. So we're going to go we're going to cast this and we're going to say info.tag, and then we're strongly typed and we're not so ugly. See See how much better this is? And we even boom. And then we commit the message. Now this, we're going to duplicate this on the other end, probably initially, and then, wow, Navi's really catching up. We're going to duplicate this initially. We'll probably put it in a module, I guess. I don't know what to think about that. But getting this code to compile is the first step. So we do this. And then same here. So here we want to send this array of leak report summaries. So we're going to say bytes total. Instead of tag size, we're going to do the same thing. We're going to say whatever. We're going to put a tag at the start of that. And we're going to say times I'm a little bit torn on all this, right? So one of the reasons to do this is like, hey, we can send the data to another machine or whatever. But if it was just going to stay on shared memory the whole time, you wouldn't have to do all of this. You know, I think that's a future experiment. Let me start my tea water. How's it going, everybody? Okay, we got the good old Winnie the Pooh mug. We got our teapot. We got our golden monkey tea. It's gonna get nutty up in here. Ooh, 15-11. Okay, we have to watch the last round here while the tea boils. It's 15-11. This is what is 15-11, by the way. Is the goal to have inter and intra machine? Yeah, I mean, the only thing, so for most use cases, well, okay, there's several things. So one is maybe I want to run the game on a console and see this stuff, right? And so you want to go across machines. And another thing is maybe I want to save the data to a file, right? And so, do you see what I have to deal with here, people? Do you see what I have to deal with here? So it's SMGs versus AKs. Oh. Oh, they might have just lost a round. What is happening? Ah, see, if that had been the last round, that would have been. But it wasn't. Oh, now it's a pistol round? What? The curse of close CS. I know. I should have known better. I should have known better than to think, oh, this will be the last round. Dude, we've seen finals that go to 25. Yeah, the best of 5 grand finals is necessary. It is necessary. Oops. Dude, Astralis was kicking so much ass for a while. And then what happened? Okay. Oof. Well, we're in OT now. All right. Let me get my T, my OT. I had hoped Astralis would just take care of that, you know? They were just destroying for like 12 rounds. And then no longer are they destroying. Dude, I swear it's OT every time. I think it's rigged. Hashtag rigged. Hashtag rigged. What is this like weird graphics? When did they put those barrels on Dust 2? Anyway. Is that new? Is that like a brand new change? Those weird blue barrels on Dust 2? Okay. So, we're setting this up. We're saying, here's the tag, here's the number of summaries. We mem copy the data. Okay. This is not everything that we need to send. We're going to need to send maybe these group infos, and we're going to need to send like, I don't even know. This is confusing because like we're doing this step where we summarize all the allocations and then send it over the memory or the network. And it's like maybe you want to send the data before summarizing, but then it's more data. And then that just means you know, in cases where you're actually going over the internet, it's more annoying. Okay. Anyhow, let's see if this compiles. It does. Yeah, let's make sure this is actually loading. Cowabunga-oriented programming. Oops. I mean, okay, I did all that and it compiles. So here's the deal. This is where this kind of thing gets a little annoying because we're doing dude, Astralis is already losing. So you have this example, codex view. I want to make it a shortcut here. I can't do that, I guess. Dude, Windows, create shortcut, properties. And we're going to run it on that. And I think we did that, right? No. We don't do command line on this program. That sucks. All right, well, rip. Anyway, doesn't matter. Kind of, I don't know. We might want to improve the ergonomics for this. But the point being, we're going to put another button here that says heap or something. Allocations. Right? That button is going to say that. Okay, so codex view and I don't know. Why is this not source main? Probably. Nope. Sidebar. There we go. So we're going to add another button called Alex, not Alex Baldwin, but allocations, live allocations. Now, we don't even care about this yet because we can't really draw anything. Let's at least make the screen for it. Let's at least make the screen. So, draw live allocations. Okay, now what's that going to do? We're going to have a new file. Where's this draw metrics? Dude, 16, 16. Okay, so we get a region, right? So draw live allocations. This is within that client program. We get past a region. We're not going to do frickin' anything yet. We're going to have an update live allocations. We're going to have an init live allocations. All right. We're going to add this to source control. Source. Okay. Now, should I pour my tea yet? I don't even know. Yeah, so we were playing around with dinit or uninit, and those words are all awkward, so I might go with fini. I'm trying it out. Like, it's at least 4 letters, and you know what it means, and it's not that many syllables, so we might go with fini, and it's kind of funny. Fini. Fini. Yeah. It's just, just trying to find what the conventions are. Tinny, yeah. We could go tinny. Dude, that's such a wide peak right there. What was he doing? Okay. I'm going to pour the tea. You can see how it is. I'm going to go get a little bit of milk. Let's just, okay, before I get the little bit of milk, let's just, oh, that's the totally wrong window, this one. So I'm just going to go, yeah, let's go. There we go, that's what I was looking for. I'm going to just have a little command here. There we go, pressed graphs, redeclaration. Because I pasted too much. Draw live allocations. Oh, because we don't load the file. See, it's good to try to compile your thing. There we go. Okay, so we've got our new button on the side. It doesn't draw anything. That's fine. That is fine by me. Golden monkey tea is very good. One second. Also, this will be the inaugural tryout of the big ass jar of honey. Good times. Good times. Dude, it's 17-17. And this is why I'm not trying to watch this game while programming. It is 17-17. Honey. Dude, the jar of honey is so heavy. It's so heavy. Oh my goodness. All right, well, Navi just planted. They just planted the spike. What happened to the honey bears? I mean, they got used up. Have you seen how much honey I do? Also, honey bears are kind of annoying. Also, they're plastic, usually. Oof. Smoked! All right. So we have our button. We have our screen. Now, when we init this stuff, just kill some of these li files. So when I go to certain files, I type the name and then completion it. And when you just have a lot of buffers loaded, there's like other completions for that I don't need, so I'm killing them off. All right, so we're going to import shared memory, what's it called? Shared memory channel. All right. I forget what the channel name is going to be. So many module. Oh, we want to look at visualize memory debugger. That's it. So, what is the stuff let's just make this like a protocol here. Okay. So this hash size, we don't need this anymore. This is the stack traces info. This is the summary info. And I guess, like, like you kind of want, oh, they won. They're all man-hugging and stuff, so I guess Navi won. Just in time for Avatar 2. Maybe they will star in Avatar 2. Could the shared memory channel work between Windows and WSL? Yes. So it does not expect any common address space or operating system. As far as I know, like we'll have to test that. The problem is I don't have WSL set up to do rendering, and like I'm not even about to try to figure that out. So I don't know. But the shared memory channel, we're only doing it that way because that's the highest performance thing. And it's very trivial to like, hey, here's an 8 megabyte message, just go, right? Eventually, we're going to have to do machine to machine as well. So you'll be able to switch which way that you're using it. Actually, no, because with the shared memory between Windows and WSL, I don't think there's any way for that to work. No, because the way, unless WSL lets you bridge, like the problem is the mechanism for learning about what shared memory is available on Linux is, it's a file descriptor thing, and on Windows it's a different thing. So there's like no way to bridge that, as far as I know, unless they did that somehow. But like I said, we're going to have to do machine to machine anyway. So it'll be fine. Like you would be able to have your thing running on Linux and visualize it on Windows or vice versa. Just not yet. Like most people, the very first thing they would have done was TCP, right? Most people would have started doing a language server protocol situation and like sent JSON packets and shit. And, we're not doing that. That's fine. All right, we're going to copy pasta this stuff for now. So, like this seems kind of weird, but to share this code between like a client program and it'll probably be more than this, right? To share this code between a client program and a, what's the client? Between a visualizer and a program that's running and wants to send the data, you want to synchronize on all this stuff. And so I guess we put that protocol into its own module. And while we're doing that, we might as well put the shared memory channel creation into that module. Probably. Let's call this memory visualization, because that's going to get duplicated as well. This is how we find the shared memory segment. All right. Okay. So we have this weird thing where the reader creates the channel right now. I don't know if that's how it's going to stay long term, but that's how it is right now. We're just going to do it and make everything work that way. So it might be better. There's reasons to believe it might be better for the writer to do it. But I'm not going to worry about it until it becomes a problem. Okay, so init live allocations, we're going to say we want to do some kind of reader create channel, right? We had our read example from last night. And we're going to do our fini situation and okay, memory channel is a I don't remember what it's called. We'll figure it out. Okay. So we're going to have this that says that, and we're going to go draw a message on the screen. Okay. And then here, we're just going to return. Okay, otherwise we're going to do some kind of poll for message. We'll just shut it down if there's a fatal error. Fatal error just means, you know, somebody put garbage in the buffer and it didn't parse correctly or whatever. And then we just chuck it out. Machine would be over UDP. I think it would have to be over TCP generally. Or a reliable UDP protocol. I mean, it depends. So it depends on the kind of data. Like, that's kind of the point. It depends if you want the data to be lossy. Okay, so here's the fucking problem, by the way, with the internet. I don't know. I don't want to say what the fucking problem with the internet is. Let's not worry about that. How would that work? You thought this is some kind of DMA thing. It's a shared memory thing, but it's not even in the same address space right now. Like, we don't force it to be in the same address space. So you can't read through pointers anyway. Because we want this to be also able to run on remote machines, right? We're just doing this. So it's by far the fastest and least restrictive way to do inter-process communication. Now, in theory, so I mentioned this a little bit before, in theory, we could be doing this totally differently. We could say, here's some shared memory segment that's like huge or whatever. And on the client, I'm just going to, whenever I allocate from my hash tables or whatever that's storing all this information, it just goes in that segment so it's visible to anybody. And then anybody who knows what those hash tables look like and stuff can just navigate them and follow pointers and stuff. That is different from what we are doing. And the reason why is because I'm not sure. Well, we're going to want to do machine to machine, right? And also, which you could also do, like that's, like if you can guarantee the same address space across machines on different operating systems, which seems challenging, but if you could do that, then all this stuff would just work. But also, you know, we might want to save out a snapshot of this, right? Because part of this tool that we're loading this into is, why do I have Discord running over here? Part of this tool is static data, right? Like your, you know, just what the procedures are and what the code metrics were and, you know, what the call graph was, which we haven't put in yet, but we're going to. And so you might just want to save a snapshot of like, this is what the allocations looked like for this program at this time. Maybe. I don't know, right? But it all seems to imply. How does the client know where to read? Well, we're doing that right now. So we set up a protocol buffer here. Oh, wait, we don't want to call it Cowabunga, by the way. That's not, we want to call it this. So basically there's a mechanism on both Linux and Windows where you can just look up shared memory resources by string name, and that's how you establish the network connection, so to speak. Now, right now, I'm not preventing more than one person on either end, and I need to figure out how to do that. Like there's probably in the end going to be like a slower buffer that anyone can post to. And when you go there, I say, here's the name of a buffer to go connect to, right? It's like a connection establishment thing. Okay. Anyway, so when we update, we want to see if there are any messages. Okay. And then we're going to go handle message. Easy clap, right? What is handle message going to do right now? Nothing. In fact, I don't even think this is a pointer, right? Okay. Oh, and then we have to say done with message. Reader done with message. Okay. This is going to be a pointer to void. That's going to be annoying when we try to factor this out into a module because it's like, oh. All right. Reader channel it's called, wait. Is it called read channel? I just literally made these things last night. You would think I remembered. Channel data bytes. Channel data bytes. How big? I'm thinking 64 megabytes. 64 megabytes. Okay. Channel. Memory channel. All right, well, we apparently did that. We're not drawing anything yet. I mean, in theory, this will actually do a thing, right? So if we run our client, I mean, probably our messages are malformed and stuff. They're Draco Malfoyed. But, okay. So now I'm going to go to the Sokoban. I'm going to recompile it just in case. I should do this with a program that starts up faster, by the way, for the purposes of not going insane. We should do this on invaders, actually. It's just a much, like we're like compiling GL shaders and it takes a year because that's so goddamn slow. It's occurring to me that there's all sorts of other stuff like we're not saying what the name of the program is in the messaging or anything. That would be a good thing to do. We're still loading shaders. Like the entire goddamn startup is loading shaders. Imagine how fast we would start up if we didn't have to do that. Okay. Oh, guys, we're never calling any of this stuff on the. Okay, see, we get our leak report. That's exciting. we are literally never calling that update thing. All right, so let's go to invaders so we don't have to load GL shaders all the goddamn time. Now, when we do this, we're just going to hard code this for now. Eventually, we'll figure out better ways to dynamically turn this on, but we're going to give the basic module. We're going to say memory debugger is true. And then visualize memory debugger is turned on by default because it's not actually expensive if there's no client running, right? We only send the data if there is a client running. So, we'll figure out some way to do that better. But now what we're also going to do is manually call this once per frame. Actually, you know what? Yeah. Let's do this. Okay, so now in the middle of the memory debugger, we would maybe call this once in a while. How often? I don't know. We would probably check a timer or something. Right now, I just don't even want to deal with that. So we're going to call this manually in the middle of invaders. Where's our, so simulate. Okay, here's our per frame proc. We're going to do it down here. And I'm just going to put a no check in here. This is just like how you get things going, right? Okay. We were not calling those functions, so they were getting dead code eliminated, which is why they compiled. I should have thought of that. Visualize memory debugger, mismatching levels of indirection. Yeah, okay. So we've got a little bit to fix. 71. Wait. Stack traces pending. Really? Oh, yuck. Oh, I don't know if we ever put anything in there. Those are the stack traces that we want to, yeah, we don't even ever put anything in there. Find or add. Find or pack. So in order to do the memory debugging efficiently, we put stack traces into this packed representation in a table, right? What's it called? Visualize memory debugger. So if we're doing that, we're going to say array add stack traces pending packed, right? Yeah, that's a pointer. All right. Bytes per summary. Oh, well. Okay, so that's... Okay, bytes per summary and visualize memory debugger. report sorted summaries dot count times size of type of report sorted summary 0. All right. Redeclaration of success. We're getting tired of winning. All right. Why do we have random italics? See this? Look, it just starts, the italics start here. Oh, it's because this frickin' console doesn't clear italic state correctly. We remember this. Okay, so this is running still. This goes, unable to connect to a memory visualization client. In Writer Connect, unable to map a view, error code 2, the system cannot find the file specified, which means maybe this guy didn't start that up. Right? Right? Because we're not calling it, are we? You know, I do this thing where I just type code. And then, you know, I don't type the rest of the code that calls the code that I typed. I just type code. You know what I'm saying? Like, let's just do that. All right, and then in here, we're going to do that. Okay, so that's invaders. Oh man, this is going to drive me nuts. We might have to hard code this to load some things. Okay, so invaders. It connected, dude. Hey, look, we're getting the messages, guys. And then I think I died, so I lost invaders. Right? Yeah. We might have to do invincible mode. We might have to do all sorts of things just for ergonomic development of this. But see, we're getting all these packets. And now we can start. They're at these offsets into the buffer. It's a frickin' 64 megabyte buffer, so we're not going to wrap for a really long time. Success so far. Is an if statement faster than an if expression? No. Here's the thing. If you have an if expression, then the then and the else clauses have to return values that type check consistently with each other. That is not a constraint if it's an if statement, right? Now in languages like Lisp or whatever the hell that don't do type checking, it's not a problem. But in a statically type check language, it becomes a different thing. If you say there's an if expression, you're placing a constraint on that expression. Do you know what I mean? Okay, so now we typed the rest of the code. That was good. Now, in handle message, instead of saying message exclamation point, we're going to say if message.tag is equal, we're going to go complete here. We're using language features. All right. Case reset and tell version. Case add stack trace. Case update usage. All right. I mean, I'm just going to do this. Update Usage. And then case error in handle message received invalid message type whatever, and that's message.tag, and then we're going to do okay, that's it. And then we're going to make stubs for these. Okay, hold on. Okay. It's called user read. Let's see. Data is message.user read pointer, I think, right? Let's see. Dude, I wish I could get this fucking console to just have scroll back. Like, it mixes the command scroll back with each other by default. There's probably an option to prevent it from doing that. I would like to know that option. All right. Tag is not a member of read message. Oh, really? Shared memory channel. Read message. Oh, right. Yes, we have to do a thing here. We want this. Tag if message dot, okay, hold on. User read bytes is less than 4, log error in handle, I don't need to say error because log error says that. In handle message, user, the message is too short. It was whatever bytes. Like, I mean, let's just make a function called fatal error return and respond to fatal error. All right. There was one more of these. Because we might do some other stuff, right? Okay, so now, this is good. Now what? Oh yeah. So we want to say tag is, what was it called? Viz protocol tag message.user read pointer. Do we want to pass the message? I mean, I could just get an array here. Let's do that. Okay. All right. So we're going to say back, these are the protocol things. So reset until version, we're not doing as a struct. So we should probably go back and do that as a struct. So let's say version info. I don't know. And it's got some other stuff. Okay. So we're going to say info is cast version info. Let's have another function called check minimum size for array of type, right? And then we're going to do this. So this is going to be stack traces info. This is going to be summary info. All right. And we might even put this in the frickin' protocol module. Like, I don't know. Right. Okay. Okay. And now we're going to say we're just going to paste this. So this will just sort of prove that we're dispatching correctly out to all these things, right? Okay, we need to do this check minimum size. If array.count is less than size, log error when handling a message, it was too short. We only got bytes, but we need at least whatever to hold a whatever. That's, so we got array.count bytes, and we need at least size to hold a type. Respond to fatal error, return false, return true. Okay, so we're just, we're preemptively bulletproofing. Why? Okay, this is important. This is important, people. Why am I doing all this? Am I trying to be robust against attackers? Not really yet. Am I trying to be robust against bugs? A little bit. What I'm really doing is making it feasible to develop this code in a short amount of time. Because when you're writing this code, you're going to make mistakes in packing the messages and whatever the hell, right? And so when you have this kind of checking, you detect the problem immediately, right? Which also, by the way, helps anyone who is, taking over this code later and working on it. It just makes it a lot better. In the old days, I wouldn't have been preemptively adding this much checking, and it would have taken me a lot longer to write this kind of code. All right. Oh, yeah. Okay, so let's go back to this thing. When we send the, see, I'm just putting this into like an array. So we're going to say bytes total is size of version info. Bytes total. All right. Version info of message.userWritePointer. Right. And we're just going to say info.tag. Look at how much shorter this becomes. And info. And we're probably going to want to add more things here, like I was saying, like strings and stuff. I don't know, U64, that's fine. So tag is not a member of read. I did it again. Oops. Or no, actually, it's more like I didn't finish. So the reason we did all this is so we could say tag. All right. If we got a fatal error, please stop looping, please. All right. So that compiles. Tag is not a member of version info. Oh, wait, we're getting somebody else's version info. What? Okay, because we gotta compile a redeclaration of variable version info. Let's just call this, this is not a struct that we're gonna, so, you know, I could go work on clearing up that namespace conflict, but version info, even if you see that in a debugger, you're gonna be like, version info for what? It's a constant tension between short names and unambiguous names. Tag is not a member of version info. Because I didn't do this one. All right, so. Okay. Now we don't actually need to be on a screen to be receiving these messages, I don't think. Hey, look. Here's a bunch of stack traces. Also, if I go to the beginning, we should see reset until version. There we go. Boom, and then all these stack traces. Awesome. Now what? Well, for the reset until version, what do we do? So how do we want to I guess if this is a protocol module, this is going to be in both of them, right? And you just compile against that, and that's how we know that we're new enough. Okay. If info.version is not equal to viz protocol version, log error, reset and tell version message. Disabling. Okay, so now if we don't disable, that means we're good there. Add stack trace. This is a little bit, this is where it starts getting interesting, right? Because we maybe want slightly different things out of these two systems. Because like the code was written as a leak reporter, so we care about individual stack traces and stuff. But here, maybe I care about what allocator, but maybe we care about that later to like color it with or something. Like initially we could just pick arbitrary colors just to get something on the screen. And we're not sending this usage message at all yet. So here, media molecule struct versioning system. Yeah, I'll read what they did. Like the thing is, I just don't want any of that right now because I just want to get this functionality going this weekend, right? So I'm not going to worry about versioning. Long term, of course, you would like to do versioning. And we have a way that we do versioning in the game right now that works pretty well for us, but it is involved. And I would like to figure out how to do it in a less involved, more lightweight way. And absent that, I'm fine with just punting and saying the versions have to match. I don't expect this protocol to be updated very often, right? So, I mean, initially it will, right, as we work it out, but eventually it'll just stabilize. Like, here's the thing, you know, once things are an open standard, they kind of freeze anyway because standards suck. So, yeah. Anyhow. What is happening? I kind of want to start up a snack So I think I'm going to go get that queued up. And maybe boil some more tea water. And then what we're going to do is, I guess we're going to start making hash tables of the stack traces. And then we'll report. We could report now we have this many stack traces or whatever. And it's interesting. I think we want two tables. I think we want to map address and hash. And then we want to reset these, right? So we want to table reset address to stack trace, to packed stack trace, and table reset hash to packed stack trace, I think, right? Wait, this is in the wrong place, by the way. We want to pack one of those with every... I was looking at that thinking, this doesn't make sense. Yeah, okay. Yeah. It's banana time. It could be banana time. That's not a bad idea. Back in a second. So I'm trying to do a baking frozen tater tots situation in addition to a banana. And, well, I had these little, like, cookie sheet things. And maybe they're still in boxes since I moved. I can't find them. So now I don't have anything to put the tater tots on. So I might put them on like a small metal saucepan and bake that. Or I might try aluminum foil. I have until the oven heats up to figure this out. You can tell how much I cook. This time I'm going to be sophisticated and do a little wash over the golden monkey tea. That's not how you peel a banana. What are you talking about? What are you talking about? Oh, yes. Well, okay. So, for every packed stack trace, this is where it gets weird. Because packed stack trace starts to be like a thing in here, right? Oops. Like packed stack trace is not a protocol struct. I mean, we could do this. And then we would do that. Now, this is weird because, okay, what is stack trace node? It's a procedure info, which we want, I think. It's got a next. It's got a hash, a call depth, a line number. Do we care about this? I think we do. I think we want the whole thing. Okay. So we're going to have to just make this work on both sides. All right. Let's do, since we've been working on the reader side here, let's do that. So that now is going to be small num traces Okay. Oh, wait. This is only for one stack trace. I got confused. Let's call this single stack trace info. We're going to be a full stack programmer here. We're going to do this because we're adding these one at a time. Okay, this makes sense. Okay, this is weird. We're going to end up with a philosophical problem here, which is I'm not going to worry about it yet. We'll get to it as we get to it. Okay. So we have this. We have this single stack trace info. Okay. And now we get that. And now we get do I have advanced for arrays? If not, I will do it. Okay, you know what? We're going to change this because we want this to just return our struct so we don't have to manually cast it. And then, yes. Okay, I like this a lot better. Boy, we're making a lot of changes here. How long do we think it takes to preheat to 450 degrees? To 2,000 degrees. And that's hot. Do. And that's hot. All right. Banging that one out real fast. So our new check minimum size is going to say, my dude, we're going to return you an info, which is a pointer to type, and what? Oh, data is a pointer to U8. Advance array by size. That gives us the data. And we're going to say info is cast to type of array.data. There we go. Cool. Now, this probably won't compile. Oh, well, because I didn't delete all the codes. Return false. No, don't return false. Let's do this even. No. Actually, wait. All right. So now we still haven't made these frickin' tables. Redeclaration of info. I still didn't delete all the codes. All right. So now here, import hash table. We're going to have, this is a table from, we're going to make these void pointers for now because we don't have a stack trace yet. That is a U64 to void pointer. Okay, let me check the oven. Back in a sec. Okay, I went for the just spread out all over aluminum foil version of the pan. It says, or of the tray, whatever, it says 28 to 32 minutes, which means 1:45 we have tater tots. Now, where's my frickin' phone so I can send an alarm? Okay. Alarm for, actually, let's do timer. Timer, 32 minutes. I imagine the aluminum foil will not be getting too hot and transmitting heat into the tater tots, so it may take longer. All right. But we will console ourselves with another tea with some very valuable, delicious honey in the meantime. So this honey is very runny. And that actually makes it a little harder to scoop because it's very easy to make a mess and it goes everywhere. Okay. So we have this thing. We are not now sending the right thing because our this thing doesn't know about single stack trace info. Okay. So we do this, we write this out. Okay, that was my oven beeping and saying, hey, I'm at 450. Okay, now, what? Now what? Single stack traces info, no. Okay, so supposedly we do this. So let's, when we come down here to our handle message, let's just say, excuse me. Excuse me. When we get a stack trace, let's just, okay. Oh. Let's just see. Bro, how do I just have the right command? All right. So we are getting sensible stack traces still. This is the hash. This is the pointer on the remote side. And this is the number of nodes. Now, I don't think we're actually going to try to, because the stack trace nodes have pointers in them and stuff. And that may be a little bit of a hassle to get all that data over. And it'll cause me to question my life choices. So what we're going to do in the meantime is we're going to move to just get these things on the screen. Like, these are individual stack traces that we know about, and we know what the nodes, we're going to pull the node data over. And then we're going to do, so we are not even sending right now the message for update usage, which is these summary infos that we were talking about. And we want to get those over because that tells us actually how much memory we're using, right? Without that, we just maybe know some allocation sites. So once we know how much memory we're using, we can actually start graphing useful data on the screen. We can say, hey, there's this many allocations for this much space from this many different stack trace sites, right? And then it's like, well, yeah. Now here's the thing. Here's the thing that I'm thinking. Longer term, there is a question about how do we handle the UI here. There's, okay, like I said, we're visualizing this stuff that was like some leak detection that I put in a while back, right? Except if you run it at runtime, it's not leak detection anymore. It's like just like active memory detection. And we want to see what that is. What is the active memory? What was I going to say there? I was enjoying my tea so much when I drank it, it wiped the thought out. So we're visualizing the active memory in the program, and there are things that are just useful to know. Oh, well, the point that I was going to say is the following. There are configuration structs that you can pass that says, for example, oh, the following things I count as allocation routes in my program, right? Group the following things together. But when you're flipping through something visually, it's quite likely that you'll see some stuff where you're like, no, group everything from here. And you want to kind of put that in the UI. And so, like, I'm not sure if we have a protocol going back the other way to modify how it happens, or whether on this end we group summaries ourselves also. Excuse me, also. That just sort of changes where we want the data to live and all this stuff. I don't know. We're going to see. Okay. So first we take Manhattan. You got to take Manhattan before you can think about Berlin at all. I just now realized what that song is about. I never understood it. It always seemed pretty cryptic, and now I understand that. It's obvious, actually, in retrospect. How did I never understand that song? Okay. So when we read these stack traces, let's start doing some stuff with them. Like I said, it's a little bit weird because we're not going to totally use all this information all the way yet. Also, it might be about time. Okay, before we do that, this copy pasta scenario here is not going to stand, and it's going to start causing bugs and stuff. So we're going to make a new module, and this may not be the right thing to do, but we're going to add makedir modules protocol for memory visualization. That's just going to be a single file. And why does it have such a long name? Well, if you do this for a few different topics, they could be called protocol underscore whatever. And it just helps organize the names, maybe. I don't know. Right. So here we're going to say import protocol for memory visualization. Okay, we're going to do that over here. And whoops. I literally, see, I literally made a folder. Why did I do that? This is what happens when I don't eat yet. Okay, hold on. Because I started thinking, oh, it's going to be a folder. And then I changed my mind halfway through, but I still had the make dir, right? That's not how you succeed in the games industry at all. At all. You do this. You go modules, protocol for memory visualization. All right. And we go back here and we go there and we go there and we delete this. And then we go to here and we delete this. And then I'm going to go to the changelog and tell the people okay. So we are telling the people, let's make sure both of these sides still compile. That's great. That's great. Okay, cool. Now we don't have the copy pasta anymore. We can put our protocol changes there. Okay. Now we have these hash tables. Don't we? Where'd they go? I'm in the wrong. How did I end up in the wrong? I've got too many files now. I wish Emacs were better. God damn it. I forget the name of... I just want to know what was like 2 or 3 buffers ago, and there's probably a way to do that, but because there's too many commands in Emacs, I don't know what it is. And because it's impossible to look anything up, I don't know what it is. Examples, codex view, source, live allocations, that's what it's called. Please remind me next time. That is what the file is called. Recent F. I don't know what that means. Okay. Now, init live allocations, find, okay. So the tables, what's her job? Tables. We are doing something. When we get the stack trace, we're going to go table add this mapping from the address, which is we don't have a struct for this. Like, this should maybe be in the protocol. But I want to separate it for a bit. Okay, so PST We're going to copy the data out right now because we don't care. Oh, info.address. Oh, right. Actually, no. Sorry. I'm just going to put this on here because I want that stuff. pst.info. We're going to dereference that. And we're just going to do this. Oh my God, dude. I get campaign contributions, or not contributions. Somehow, okay, I do not live in Arizona. I never have lived in Arizona. I don't even think I've spent a night in Arizona, ever. Like, I've driven through the state of Arizona. That is the limit of my interaction with the state of Arizona, I think. But because I donated to somebody like years ago, like Andrew Yang or something, right? I get on all these fucking message lists for like loser Democrat politicians. And I'm using that adjective because I'm so pissed off. Like, I keep getting text messages from the Mark Kelly campaign in Arizona, and they're all like, make him out to be like such a sweaty, depressed loser. Like, oh my God, we're missing our totals, our expected campaign totals by so much. Will you please help us out? But like, I'm not even giving you the right way that it feels. Let me read you this text message that I just got, right? And they're 100% like this, and it's all emotional manipulation. Okay, no, you know what? Let's do the screen share, right? Let's do that. This is a good brain break, right? We're doing Pomodoro right now, aka I'm distracted and don't want to work. What is the screen share thing for iOS called that we use? AirPlay. AirPlay is the marketing name. So, okay, so shut up. Let me use it. AirPlay. Screen mirroring to Warrior. It's such a joy when things actually work the way that they claim they're going to work. Like, it's so rare. Okay, these are just the two messages. Tough news from Mark Kelly. We only have a few hours before our May fundraising deadline ends, and we're short of our goal. We can't afford to miss again. Not with so much spending against us. Please, blah, blah, blah. Is there anything we can say to convince you to contribute to Mark Kelly's re-election before midnight? What if we told you Trump is speaking in Arizona next week? What if we said we were short? He's like such a beggar. Like, you'll never get a girl to go out with you like this. Okay, this is not even the worst ones. Let me see. I might have deleted some other ones, or they came from another number. Let me see if I can find. I might have deleted them, but it's just like non-stop. Okay, here's some more. I have from 3 different numbers. Okay, so this was the first one, right? Here's from May. Wait. That's the same. Oh, wait, there's one other. Okay, hold on. Here was, now I must have deleted the older ones, but here we go, right? I was already fed up. I said, every time you text me, I donate more to Blake Masters, which I don't because I don't live in Arizona. But I just like, okay, here's the thing. See this photo with him wearing the tough Navy shirt and the American flag and stuff? This dude's an astronaut or ex-astronaut, all right? He's supposed to be like a badass motherfucker, like in principle, but his texts are all like whiny bitch texts. Like whoever is running his campaign lost the campaign for him by doing this shit. And these are not even the worst of them. I mean, the reason I was so fed up to send that text, like this was in February. I'd already gotten so many that I was angry. I wish I had the rest of them to show you, but like they're just bombarding you with texts that subliminally say, I'm a loser, please give me money. And that is not going to win you anything, right? It just makes me not like you. Yeah, I wish I hadn't deleted the rest. Yeah, shouldn't it? Yeah, he's an astronaut, dude. Like how, like run the astronaut PR campaign. Yeah, well, that's why it makes me angry. So firstly, a loser begging you for money automatically, it's one of these things that human beings implicitly, like, we know what that is and we don't like it, right? Like, you know, if someone's your friend and they're asking you for money, you help them out, right? If you don't know someone and they seem like they're in a plight and they ask you for help, you help them out, right? But like if someone's habitually being a loser and asking you and is a constant drain on you all the time, we have psychological defenses to that. And he's invoking those defenses. Why? Why would you do that? Seems like the odds are 50-50 in the Arizona election. I don't know. I mean, I think Blake Masters is just going to wipe it. I think he's just completely winning. I don't think it's 50-50. I mean, I don't live in Arizona though, right? So it is what it is. You don't get why lessons aren't learned. I think the problem is, again, that everybody in the Democratic political machine is subscribing to their current version of the culture war, which involves everybody constantly checking everything over and second guessing everything and telling you all the things you can't say and how you can't say them and stuff. And so I think you're not allowed to make a strong statement anymore if you're a Democrat at all of any kind, because it'll just get, whatever that statement is, it'll get whittled down before it gets out the door. And so you can't say anything and you can't do anything because they've just torn themselves up. You're in Arizona and all you see is Blake Masters. Yeah. I mean, I can't say I agree with 100% of Blake Masters' platform. I think he's a little too extreme on some points. But if I lived there, I would be voting for him anyway because he's way better than anyone else in the race that I can tell. Yeah, like how do you lose if you're an astronaut? And part of the reason, so Mark Kelly already was elected, right? He's running for re-election. And so part of it is like, he was not a fucking astronaut in office. Do you know what I mean? He was like just a complete wimp in office. So, I don't know. I mean, again, I don't live in Arizona, but this is my perception from far away. Not gonna lie, I peeked at the tater tots and they're looking pretty good. He had an astronaut in office in Spain and he was not up to the job. Yeah, I wonder if. Here's the thing. So, astronauts, definitely, they are brave dudes who go through a lot of very tough training that requires you to be capable and smart. Okay? But I wonder if astronaut training in the 2020s, for the past several decades, in fact, is just basically super college. I Freudian slipped and said baby, but like maybe it just filters for people who are really, really, really good at following orders and who have those other properties. But then you put them in office and they're supposed to lead, right? And like leading is a very different skill set from following orders. So you can have all these other very strong personal skills, but if you don't know how to take initiative on anything, you're just going to not do anything. Astronaut training not equal to political acumen training. Yeah, but it's not even acumen, right? Like political acumen is like, how do I be effective at gaining support for this thing that I want to do among other politicians and stuff, right? And among the populace. But like prior to that, you have to at least have good ideas and an interesting plan and a good story for how you want to fix things, right? And I don't think he even had that. Like I read, because I was getting all these messages, I read a little bit of the Kelly campaign and I was just like, the dude's a nothing burger politically, right? Like, I don't know. It just, you want to do additive manufacturing in microgravity. What kind of materials can you use in microgravity? Like, do you just get better bonding there and stuff? It seems like it would be annoying. Like a lot of how the cheaper 3D printers work is they rely on gravity to put the stuff where it goes. You don't need support structures. Oh, that's true. But the support structure generation, dudes, so during COVID, I got a little bit into 3D printing, not super into it, but like, you know, I was just printing out stuff and seeing what these model generators look like and all the support structure stuff. Dude, the support structure generation in all these programs is just like complete shit. Even the later improved stuff, but the default stuff, especially in some of the freeware programs that like makes like the little spiral tubes everywhere, it wastes so much material and takes so much time, right? What you want is like parabolic arches that use minimal material and reach out from the side to where you want to go. And it's not that hard to figure out how to insert these into, into mesh files. It's just the people whose job this was were not up to the task or something. Like, I don't know. It was funny how bad the support structure generation was. It was just comically terrible. He was selected by the party exactly for the same reasons he was successful at Super College. Yeah, well, that's why he's going to lose now, though. So maybe that works for a while. See, here's the thing is like Blake Masters, he's running a little bit of the Trump playbook of just blatantly say strong statements that you know a lot of people believe that are not popular among the other side, right? He's running that playbook, but he's also like not a bozo, right? So, I don't know. It'll be interesting to see what happens there. The root of architecture is arch. Good point. That is a very good point. Like, dude, it was astonishing how bad the support structure generation was. It was freaking insane. I was tempted to just do it, except I didn't want to deal with, you know, trying to work in that kind of software. Okay. Oh, that's the timer. Let me go get the tater tots out before they burn. What you heard about Blake Masters from across the pond is kind of concerning. What did you hear? I'd be interested in knowing. So now I have to deal with getting a sheet of tin foil at 450 degrees out of the oven. Which I'm going to let it cool off for a second so I don't burn myself mega badly, and then go attempt that. Okay, meanwhile, we can start looking at programming again. What was I even doing? We were looking at stack trace nodes. We were adding them to the hash table. Now, this mypact stack trace is going to be just this. Okay, so mypact and then we're going to mem copy. We'll make sure that the data is big enough. We'll have another version of check minimum size. We're going to say OK is check minimum size. So we'll say stack trace node data nodes bytes. We return. Otherwise, we mem copy. We'll do all this allocation after. Mem copy pst.nodes.data data.data nodes bytes. And then we add it to those tables. We're going to just print this. Okay. So now we've got this. It's in two hash tables, etc. We need this check minimum size. This is a different overload. Um, this is much easier. Okay. The data area was only, but we need at least size. Yeah, we don't have a type here. There we go, false. And then this is true. That's the wrong program. There we go, data and size. Oh, wait, let's get rid of that. Hold on. Bytes. And then 119. Oh, that was that. Okay, cool. I have to take a lot of news about American politics in Europe with a grain of salt. Yeah, that's for sure. He subscribed to something called the Great Replacement. No, okay, so here's the weird thing. Okay, I am very limited in what I can say about this without deleting the VOD, right? But like, as somebody who has no interest in this part of politics, I observe the following thing. Like, there is all this stuff about, hey, the Great Replacement theory. Like, I've seen that. This is like a PR kick that's been going for a while. There's this thing called Great Replacement theory, and it's like essentially right-wing Nazism and whatever. And it's very confusing because the first time I heard about the Great Replacement theory, it was from Democrats saying, and they still say it, right? They say, you know, according to the following demographic trends, the future of the USA is the following thing, and that's great. And we should do what we can do to accelerate that. Like, Democrats say that. Like, so this is the thing, is somebody who doesn't really care about this, again, I'm confused because it's not a conspiracy theory. You can't simultaneously say it's true and good and that it's a conspiracy theory, right? So what they're really trying to say is, we don't like that this other party is opposed to this demographic shift, which, by the way, I don't think anybody denies is happening. Like, you just look at the demographic trend of the United States. So how is it a conspiracy theory? How is that the objection? Maybe the objection should be, look, you shouldn't think this is a bad thing. I mean, that would make sense to me. That wouldn't be disorienting. But calling it a conspiracy theory is weird, because I first started hearing about this stuff like on The Daily Show with Jon Stewart in the 2000s. The conflict comes from your opinion if that is good or not. I agree. Yes. And so, but it's just a very disingenuous form of argument. You know what I mean? Because like, you guys were talking about this for like decades, and now you're saying it's a conspiracy theory. What is happening? Like, what? The objection is whether or not it's being done on purpose. But when people talk about it and say it's good and that it's going to solve a lot of problems in the country or whatever, aren't they kind of doing it on purpose? Or they would if they could. Like, that's not, it's so weird, right? That's all I'm saying is, like, I used to identify as on the left wing of the political spectrum. Now I don't. Now I'm just like kind of homeless, right? I'm a political vagrant who has no place to go. But like, I just don't get, I don't get it, right? I do get it. It's disingenuous argumentation. But But I don't get it. I don't understand why people think that everybody's that stupid, maybe. I don't know. There's a naturalist bias. Someone is saying in chat that done on purpose equals bad, done naturally equals good. But there are certainly things that are being done on purpose that are for sure being done on purpose that are correlated, right? So for example, there's a lot of illegal immigration into the US, right? There's a lot of people on the left-wing side of the spectrum here who think that's good and we shouldn't do anything about it and we should in fact increase it. And that illegal immigration is heavily correlated with the kind of things that this supposed conspiracy theory is about. It is definitely being done on purpose, right? If we wanted to stop illegal immigration, I mean, completely stopping it would be hard, but we could do a lot more if we wanted to. And in fact, a recent president ran with one of his main campaign points being stopping illegal immigration, and he was called like a racist and whatever for that. So of course it's being done on purpose. Like what do you even mean, right? Like it's like I'm going to go crazy if I think that people think that I'm this stupid, right? Left and right is a dumb way to try to label a 10-dimensional problem. I agree. And that's part of why I'm politically homeless, because I look around and I don't see anybody who's like just being baseline competent and making sense right now. Like everybody is just saying stupid shit all the time. There's literally, if you're a thoughtful person who wants to solve problems, there's like nowhere to go politically in the US right now. Wouldn't just making citizenship easier reduce illegal immigration? Maybe. It depends on what easier means, right? All right, let me try the tater tots. Dude, these are so good, I should have made more. So I do think it would be a really good idea. I said this on a stream with Casey a couple weeks ago. I think it would be a really good idea if the US had more immigration. I think it should be high quality immigration. I think we should just let radically more people into the country, but do it by adopting a point system like New Zealand has or whatever, where it's like immigrants who want to be productive and, you know, do high value work or start companies or whatever, we should just let them in as long as they're going to do that. Like people who are net productive like that, who want to work hard, why would you cap that? I mean, unless the number was just so insane that it was destabilizing everything by the mere number. But like, that's just a net win. Now, I think, again, if a president were like, look, we're going to cold stop all immigration at the border, we're going to get or all illegal immigration at the border, we're going to get very tough on it, while at the same time radically opening up legal immigration, it would be very hard for somebody to fight that politically because it just makes so much sense. So like, I don't know why somebody doesn't do that. That would just be a winning platform. Every Western democracy is facing the same issue with senseless politics. Yeah. Well, that's sad to hear, but I'm not surprised. My plan wouldn't be reported on accurately. No. You just straight up say it in speeches over and over. Certainly the media can try to distort what you say. But if you say it over and over, and people can just watch the video of you saying it over and over, it's very hard to lie about that. Especially if the message is short and simple, a couple sentences. Okay. So we are here. Should I just try running this? Well, we got a bunch of stack traces. Cool. Everything appears to be working. I think this means we move on and we start sending more information. Okay. Now, our other message was called update usage. Let's just, when we get one, we're just going to do that. We're just going to print that we got the message. Okay. Now what? When do we send these? Well, oh, wait, we are theoretically sending them. Okay, wait, we did call in invaders, we did call this viz update, right? Yeah. So we are theoretically doing this every frame. So I'm not sure. Oh, we never send the message. That's what's going on. By the way, I have on my to-do list, making an error if you reserve 2 messages in a row without committing. And I didn't do that yet. And I made that error here. Writer commit message viz channel message. Okay. So now we are sending this message. What are we sending? The summary infos. What are the summary? Is that enough for us to do something with? Summary info. Oh, that's in our protocol. Summary info, tag num summaries. Oh, wait, that's this. Okay, and then we put reported summaries. Reported, so sorted summary, sorry, that's a leak summary. Oh, we don't want to do that. These are by pointer. That's so weird. Why are these by pointer? Let's look at this for a minute. So we make a leak summary. Oh, in the pool. All right, so instead of mem copying, we need to go wait. Sorry. Wait, what? Hold on. What am I doing? That's what I want. Okay. So we're just writing out the summaries. We assert that we wrote the right amount. And then we commit the message. Now, these leak summaries are how many calls and how many bytes, and a stack trace, which we can't totally decode yet, but this is enough. So once we have an array of all of these, this is enough to start drawing things on the screen, which is great. And that's all we need to do today to feel successful. Tomorrow we can make it fancier. Like, there's probably going to be lots of things to do just to try to, like, make it what am I trying to say? Like, just UI stuff, because there's going to be a lot of these allocations and how do you visualize them and etc. Okay. Now, on the other side, live, I remembered what it was called. We'll do this. We'll put a no check in here. Update Usage Yojimbo. And then let's actually say I'm just going to print that every time because that's a little more useful. Okay, reported summaries. Right, it's sorted summaries. All right. So I also, like, I have to run one program first and then the other. I probably want to make it reconnect and stuff. We might do that when we want another brain break from the harder stuff. So codex view, now do that. Oh, this is probably that assertion that I literally just added. See, assertions are your friend. Size of summary info plus sorted summaries.count times size of... Oh, this is wrong because it's a pointer. Yeah, that's good that we checked that because we wrote past the end of our buffer. All right. 79, 85, 85. Let's play the game. Oh yeah. Oh yeah, I'm blowing up aliens, guys. Oh. Guys, this game is from 2014, by the way. This was like one of the first demos that I did when I died when I started this programming language. Okay. So you see this number is going up and down. This is actually not that bad because at a 4K screen, which this monitor is, that's like 40 pixels per thing. That's plenty. So I think we start doing client work now. So here's what I want to do. This is being drawn all the time right now, right? Clearly, until you load a codex file. But now codex files are not the only thing this program does. Right? So I think we want to draw the sidebar all the time. And then if you're on this screen, which is the graph screen, we draw that. If you're on the info screen, we draw that probably. If you're on settings, we don't. If you're on Alex, we don't. Alex Baldwin. Okay, so we're going to do that. Okay. So here, we're going to say draw one client frame. Okay, and then all that code so draw info and draw metrics. Okay. Draw codex view selection. Okay, and then this code is just going to go here for now, I guess. Draw codex view selection in a rect. Tell the people what to do. Yes. I need to look at these because these used to be okay. We're just, you know, this did expect to render into the window, and we're making it render into this region. Okay, so now in graphs as well, where does this live? What was it? I thought it was called draw graphs. Draw metrics. It's in the file called draw metrics. Who would have thought? Who would have thought? All right. No, not invaders. So now we run it, but we have our sidebar, and we can do all these things. So that's great. Okay. Alex Baldwin. How are the tots? They are good. I have not finished them because, dude, it was a lot. But I think we will be following up. We will be following up. Okay. Let's start telling the people. My brain is at an inflection point. We'll say examples codex view. So those are related to each other. Now can visualize live reports of heap use. This is a lot. We're advanced lying a little bit. Live reports of heap usage of programs compiled with modules basic memory debugger is true. This visualization is early and will be developed over time. Okay. Okay, so this is memory visualization stuff. This next beta is going to be actually kind of huge. Is it a lie if there's no date yet? Maybe not. Maybe this is just a missive from the future. Okay, I kind of want some more iced tea. We started with hot tea. We're doing iced tea for a little while. It's a prediction. True, predictions don't always work, but they often do. Okay. Run codex view and go to the Alex button on the sidebar. Okay. Now, I mean, like maybe the maybe it just helps to have it in a different file. The problem is there's a draw metric, so that's going to be annoying, but in fact, we can steal it a little bit. Draw live allocations. Wait, we already have that. Lol. Okay. What font are we using? I guess there it's a little different. Let's go to the what was the file like literally this one, draw info. Okay, file name font. Great. label line no no program, no memory debugger client program is connected. Okay, and we'll return. If memory channel initted is true, we could do the same thing. This is going to look like copy pasta, but it's going to change later, so whatever. Text is tprint oh, you know, we want this to be scope module. We're going to say how many of each of these. So this is just how many things are in this hash table. We're drawing things on the screen, guys. This is insane in the membrane. All right. Now, here. Okay. Let's do a little bit more here, because we had this check minimum size. Okay. Let's do this. Summaries bytes. Leak summary. Okay. Assuming we have enough data, we're going to say mem, actually, cursor plus equals size of leak summary. And we're going to do the same assertion that we did. We're going to assert cursor is equal to data plus, let's just say array.data plus array.count. This just ensures that we read all the data exactly to the end, did not read enough, and did not go too far over. And let's not even print this out anymore. Okay, so we need current summaries. Now, we don't have frickin' leak summary either. So we're going to do another my here. And we'll deal with that later about figuring out what is even going on. All right, so current summaries is my leak summary. It's one of these. And then back in our draw live allocations, current summaries.count. Cool. All right. Not enough arguments to label. We need the label theme. Same here. Text. Label theme. Num nodes. Num summaries, probably. Group info. My group info. My group info. And that's going to be empty. All right. Okay, I printed the table instead of the number. Go me. All right. How many stack traces? This many. All right. My job is definitely tables right now. So, Alex, 0 stack traces, 0 leak summaries. That's great. Now, let's go over here and we'll run invaders. Well, let's recompile it just in case. We'll run it. I need to make it not go. There we go. It would have been cooler if you could have seen it happen at the same time, but the window went to the same place. Now I have to defeat the aliens. Who are cunningly dodging all my bullets. See how smart they are? Oh, yeah, that'll help. That'll help. Getting a lot of those little fork burgers. Oh yeah, there we go. Oh yeah. Now we start picking up the shields. Heck yeah. Heck yeah. Look at all those leak summaries, by the way. Oh, we lost our fork. We lost our fork. I need my fork. It wouldn't be that hard to make this an actual game. There we go. There we go. Yeah. Yeah. Okay. Now we're... Oh, we lost it. Oh. All right. Boom. So if only we could draw this data now, right? Wouldn't that be cool? Update the Twitch game. Esports ready. Yeah. Let me get some more tea. When I come back, I think what we're going to do is just start drawing some bars. So remember on the codex view, we had these bar views. And we could draw them sorted, and we can give you a little drop down controlling how to sort it. Or we could go like sorted by magnitude of leaks, and then sorted by number of leaks, right? And then sorted by cucumbers, and sorted by shallots. What about OS handle leaks? That's a totally different fucking thing that we don't know anything about, unfortunately. Like, I could imagine interfacing with the operating system well enough to have that information, but we simply do not. Operating systems are not very good at that. But this is not really leaks right now. We're not trying to profile leaks so much. They're called leak summaries because the code was initially about memory leak detection, but what it really is is active memory use. So basically, there's 96 summaries of memory use over 160 stack traces. So there's at least 160 allocation sites, or no, there's less than or equal to 160 allocation sites. Sometimes you get to a site via different traces, right? And we're telling you all this. There's get process handle count. Yeah, but that doesn't tell you like what the handle is and where it came from. We could, though, print that count, and if you see it going up over time, that's probably bad, you know. But like you would like to then say, why is it going up? All right, let me get some tea back in a second. Any more questions about what we're doing here? We're doing ice from refrigerator and tea in a wonderful plastic jug. Number was going down sometimes. You thought that meant the number was not garbage collected instances. Yes. Yeah, when we free them, they go away, right? Because it's no longer active memory use. Okay. Wow, it's 2 p.m. already. Great. Let's put some stuff on the screen. So let's draw 2 rectangles. I think they are sorted already. Let's draw 1 rectangle, right? I believe they are already sorted by total bytes, which is one of the main things you might want to know. Okay. Yeah, you know what? Let's just do this. We won't say leak here because it's misleading. Okay. We're just going to do this. Again, we're kind of posting, but it's because we're going to change all this. We're just getting it started. And then we'll worry about picking inside here and stuff. Okay. So what do I want to do? I want to do a pre-pass that sorts these things by, you know, size. So let's just get the rectangle on the screen, right? So instead of calling this entire region, guys, we're going to have a scroll bar. It's going to be amazing. Okay, so we're going to do this. Okay, our scroll theme, we're going to do that. See, we're not just totally posting with want and abandon. So we're going to do that. And then end scrollable region. We do a bunch of stuff and then that. Okay, I'm sure there are many problems, so let's just see what they are. Oh my God, okay. Wait, are we even loading this file? We are. Oh no. Oh no, how did we do it correct? Well, let's... Hey, there we go. However, we should have done this because the scrollable region has its own background. So, boom. Okay. Now what? We want to draw this rectangle. Get quad, right? We get quad of top. Draw quad top FG. Oh boy, we didn't set the shader. Set shader for color. Dang it. Okay. Whoopsie, that's at the very top. Where are we drawing that label? We're doing it way. Wait, no, that's the, sorry. Okay, this is it, this top, and top.y is line dot. We're just gonna do that. We're no longer stomping our text. That's, oh, that's ugly. So ugly. Okay. Shouldn't the no client connected message be showing? Oh, you know what? This is the wrong thing to check. This is the wrong variable. It's a good point. It is a good point. This is the wrong thing. What we want to do is connection is live. So when we get this, whoops. When we get this, we do that. Good point. Memory channel initted. Undeclared identifier. There's a file scoped. Bruh. Okay. No memory to, okay, that's a new line right there. We don't need that. We don't really strip that when we draw. Okay. Now, if I do connect, of course, it's going to run over the top again. It's like a magician trick, but there we go. And then the window is different. So that's cool. Now we are drawing a pink rectangle, which is not the best way to visualize this information. Okay. Now we start visualizing. So I'm going to make a little struct that's just called, I don't know, summary, I use info a lot. Let's just say summary box, I don't know. It's going to be a struct. It's going to have a width of something, right? Normalized, oh, I don't know. Let's just see. And it's going to have a summary, which is a pointer to a myleak summary. See, this is not good. Oh, it's fine because it only lives in this function. All right, so boxes is a whatever of summary box. Boxes.allocator is temp. Array resize. Oh, boxes or array reserve. Let's do this. No, let's do resize. Boxes to current summaries.count for all the summaries, width sum is going to be this. Add up all the sizes in bytes, then normalize dividing by, let's make that one, the sum. Okay, and later we'll have multiple ways of doing this based on the mode. Right now we just care about total number of bytes, right? So width sum is this for current summaries. Actually, this is going to have to live beyond this function, but we'll play with it. So for everything in current summaries, this is a leak summary, right? We're going to say so we're going to do this. Box.summary is it, and that's it. And then, we're going to do that. Width sum plus equals width, all right. Pass to normalize to pixel width of top. All right, so we're going to draw a little backing rectangle. Pixel width of regions. Let's draw a little thing inside, not regions, boxes. So boxes is shrink. I don't remember if that's called shrink. Okay, anyway. Because I might tweak this, which is why I'm copying that out. Current summaries, it width divided by equals width sum. Okay. And then, I mean, for now, that's fine. It width times equal boxes W. Okay. So now we're going to say R is boxes oh, actually, this is not current summaries. This is boxes. Okay. For all the boxes, now we're just going to draw them. So we're going to pick a totally random color, which is horrible. And And now we're going to go draw quad RFG. How many mistakes? So many, probably. Whoops, like not even being in the right place. Boxes is shrink. Oh, that's not boxes. This is boxes. Boxes region. Okay, not that many mistakes. Okay, boom. No client program, and we do our magic trick again. Now that, oh boy. Oh, because it's different random colors every time. But you see, well, we're also starting at the wrong x coordinate and stuff. But you see what I'm getting at. We are now, this is a historic moment. We have a live view into, well, the program has now exited, so the view is no longer changing. But we have a live view into the memory use of our invaders program. Which is badass. And we have more data than we are drawing, right? In fact, we can start by, we're eventually going to piggyback on some of the mouse, selection code that we already have and stuff. But we can start by just saying the first one, oh, you happen to have selected the first one. And we'll just print that. Epilepsy warning. Yeah, we're not going to need epilepsy warning too much, I don't think. Like, I feel like we can alternate between two colors that are kind of nice, right? And then we'll have stable colors for a while. Or we could generate the color based on the name or something. If all debuggers had stuff like this for a couple of decades, I fucking know, dude. I am 50 years old. I could have the level of experience that I have now 12 years ago, if the tools were good, maybe more. Like, it's fucking nuts how much time all this takes. But that's what we're doing here. We are making the best environment that has ever existed for systems programmers in the history of humanity. That is the mission statement. Okay, let's just pick two colors. I don't know. This is, I'm not even going to pull out a color picker for a minute. This could be a nice cyan, right? Something like that. If X, it, and it index. Okay. So that color is going to be down there. Now we got to fix the coordinates. So top, inside the scrollable region. Graph region, line height. So this is confusing me. I don't think I don't think we're correctly cutting off the sidebar. Bro. No, we are. Okay. So... Oh. I was being dumb. That's why. Boom. Boom. Check it out. Okay, that's still very ugly, but you see what I'm doing. No more epilepsy. We got killed by aliens. Okay. So, now what? We select the first one and we draw some information about it. Why is it so 1/2 to the n? I mean, in general, things are power law, right? So we have it sorted for big first, but if you imagine that this is a typical like exponential curve, just flipped, right? Where some things take most of the memory and other things take little of the memory, it's probably like that. Yeah, if only we didn't get killed by the aliens. All right, so now we're going to say selected box is a, what did we even call these? Is a summary box. If boxes, selected box is the first one. Okay, so now if we have a selected box, so first, let's save out the X box. The X box. So the X coordinate. All right. So if we have a selected box, we're going to say R is get rect, or no, let's say box rect is get rect selected box.x, r.y, selected box.width, r.h. We're just reconstructing. I didn't save the whole rect in there. I could have. Maybe we'll want to do that, but I didn't. Okay, so we're going to say we're going to pick a border, and these things could get thin. So We don't want to go more than that. And, oh, you know what? We should draw it around the outside of the box. I shouldn't do it by cutting it. I don't know how we do it in the other thing. I don't want to go through a lot of effort right now for this. This is silly. We'll just put a bottom on it for a second. Box rect h times 0.1. I don't know. This is a cut bottom. All right, and then we're going to go outline color. Very bright. We're going to go draw quad top outline color and bottom. Okay, so now I've got too many windows flying around. Okay, so you can see this one's selected. It is not a very good selection, but it's actually fine for now. We can tell. Okay, so now we have this remainder area. We have this thing called remainder. Okay. Oh, this graph scroll value is not right. That's just the variable that scroll bar uses to track where it is. Okay, so the remainder info area is cut junk. Info area is cut top of remainder by how much? Like that. So now we have some info area, and we're going to draw some text. How are we going to do that? First, by pouring some tea. Imagine Visual Studio trying to do the same. They'd show a less than 10-second prompt in the graph. That is completely true. That is exactly what they would do. Okay, well, we want to draw the info from the myLeak summary, which is going to be some number of bytes and some number of leaks, or in allocations. So we're going to say text is tprint however many bytes in whatever many allocations. And, well, that's going to be summary is selected box.summary. And we're going to say summary dot leak bytes, summary dot leak count. Okay. Now, we already have this label stuff. We'll just use the same label theme and all that for now. Line height, do we have that? Label, line, text, label theme. All right. Okay. 8 megabytes in one allocations. You'll note that my grammar is incorrect. My grammar is incorrect. Okay. Easy clap. Now, we want to put commas in these. Format int summary.leak bytes in digits per comma equals 3. It didn't do it. Hold on. I mean, it did the plurals. The comma. Oh, comma string. I mean, I feel like I should make a function for that. Oops. How cool is that? And we kind of have stack trace data. Except we don't totally. Now, I assume we're going to want to like zoom in on this and stuff, or I don't know, maybe we do a 2D squarified tree map view or something, but this is pretty good. Okay, I think it's time for me to take a break. We've been going for 4 hours. I don't even know if it's going to be that long of a break. Sorry about the mic punch. Bake arguments. I wouldn't do it with bake arguments. So what I really should do is have a thing where you just can fill out a format int or whatever and then apply it. And I just don't have that. All right, guys, I'm going to take a break. We'll be back at some point, maybe soon, maybe later, but we're going to continue this grand visualization experiment. I would have been happy to get to this point by the end of the day. So the fact that we're here means we're pretty much cranking and we're on target, and it's going to be good. All right. Thanks, everybody. See you later.